Welcome pre-cal students to class today on this Wednesday the 9th. Hope you guys are doing well. Hope you're ready to learn some math today. Let's jump right into our announcements like we always do. There'll be no quiz this Saturday, so I know you guys are excited about that. No quiz this Saturday due to spring break, which leads me to my next announcement. Spring break is next week, so men, no videos 14th through the 18th, okay? Your next video will be Monday the 21st. After spring break. So you have a video today, which is Wednesday. You'll have a video Thursday, videos on Friday, and then that's it. Okay, so enjoy your spring break. You guys have worked hard, you deserve it. And when we come back, I believe we have 4 weeks left of class, so it's really coming down to the end. Okay. All right, tests are due today, and so I hope that you are staying on top of those. And then please stay on top of your integrity sheets. Don't get behind on those. You know that they're difficult to get caught back up on. Okay, so please take care of business there. All right, well, let's do what we've always tried to do here lately. I've been trying to review every day what we covered during the week. So let's do a quick review of what we learned yesterday on Tuesday. Okay. First of all, we learned how to find asymptotes, okay? And we talked about what is a rational function. So I gave you a definition and I gave you examples of what rational functions are. Then we looked at how to find 3 different types of asymptotes. First of all, we learned how to find vertical asymptotes. Now, when I review, I'm not going to go over all the steps and everything, okay? I'm just trying to refresh your memory and say, hey, if you don't remember this or if you don't know how to do this, you might want to go back and review, okay? And then we looked at how to find horizontal asymptotes, and I gave you some scenarios here that you need to be familiar with. And then I said, let's learn how to find slant asymptotes, or they're also called oblique asymptotes. Okay, and so we learned how to do that. So there's a quick review of what we learned yesterday. Now go ahead and grab your notes, notebooks, calculators, books, and let's get started. As we just saw, yesterday we learned how to find 3 types of asymptotes for rational functions. Today, we are going to take this newly found knowledge and apply it to graphing rational functions. Men, you cannot graph rational functions unless you first know how to find asymptotes. Okay? Moving on. Here's your heading for today, Graphing Rational Functions, Lesson 3.5. The date today is the 9th. And to give you a little closure, I'm going to give you some steps here in a second, and then we're going to work out 3 problems. Okay, and then in your homework I only give you 5 graphing problems because they do take a while. Now, I did not say I've given you 5 problems total for your homework. You have 7 problems altogether. 5 of those are graphing, okay? And so they do take a little bit of time, and so I've only given you 5 graphing, and we're only going to do 3 in class today, okay? Let's go ahead and look at some steps very quickly. There are 3 basic steps for graphing rational functions, okay? Here they are. You must first find all the asymptotes. Now, you can see how that would take a little bit of time because there are 3 types of asymptotes that you have to look for, okay? Step 2, find the X and Y-Intercepts. Now, I will show you how to do that. We've not really done that yet, but you should basically know how to do that. When you're looking for the X-intercept, you put 0 in for Y. When you're looking for the Y-intercept, you put 0 in for X. But we'll work on those together. And then step 3, evaluate X values. Now listen to this. On the left and right sides of your what asymptotes? Vertical. Be sure to include values that are very close to the asymptotes. Now, like always, I will explain step 3 a little later, okay, when we get into the problems. But these are the 3 basic steps you need to remember when it comes to graphing rational functions. So let's go ahead and take a look at 3 different problems, okay? Here's the first problem. Let's go ahead and do step 1. Step 1 says find all of the asymptotes, okay? Let's start off with vertical asymptotes. Do you remember how to do that? We take the denominator and we set it equal to 0, okay? So very quickly, I'm going to do that. We can factor this. We have done so many factoring problems, students. I'm not going to go over this again and again. No, I'm not trying to be mean or anything. We've done so many of these, okay? Positive 9x, negative 2x, that would give us a 7, negative 18, pull out a 3x, x plus 3, pull out a negative 2, x plus 3. So it looks like your factorization would be x plus 3 and then 3x minus 2. Okay, now that means for this parentheses, one of my zeros would be negative 3, and for this parentheses here, one of my zeros would be 2/3. Okay, so what I do is I go to my coordinate plane over here, and at negative 3, I'm going to go ahead and put a dotted line here. That's one of my vertical asymptotes. Okay, so go ahead and do that. And then also at 2/3, that's a little more difficult to do. You understand, we're just estimating. It doesn't have to be perfect. And I'll probably go ahead and put underneath this one so I don't forget later that it's at 2/3. You don't have to do that if you don't want to. But okay, there we go. We found the vertical asymptotes, and we're going to move on. Now let's find the horizontal asymptotes. There's two scenarios when you have a horizontal asymptote. When the degree in the numerator and the denominator is the same. For example, if I had a 2 here, which I don't. The other scenario is when the numerator's degree is smaller than your denominator, and that's what I have. The degree up here is 1, the degree down here is 2, and so my degree in the numerator is smaller. That means you automatically have a horizontal asymptote at y equals 0. Always, okay? Easy enough. Whenever the degree in the numerator is smaller than the degree in the denominator, you will have a horizontal asymptote at 0. So go ahead and put your horizontal asymptote on the graph. Now remember something, students, please don't forget this. Please don't forget this. Occasionally, once in a blue moon, horizontal asymptotes will be crossed. Okay, vertical asymptotes will never be crossed. Occasionally horizontal asymptotes will be crossed. Okay, so do understand that. Okay, moving on. Step 2. We're done with step 1. Step 2, find all the x or find the x and y-intercepts. Okay, well actually y is the easiest. Everywhere there's an x, I'm going to put a 0. So let's real quick find the y-intercept. Everywhere there's an x, I'm going to put a 0. And here's what I end up with. 2 times 0 is 0, plus 3 is 3. 3 times 0 squared is 0, plus 7 times 0 is 0, minus 6 is negative 6. So I'm getting out a negative 1/2. So I know for sure, let's do our graph in green. I know for sure the graph is going to cross the y-axis at negative 1/2. So put a point there. You know for sure the graph will go through that point. Now let's find the x-intercept. Here's where it gets a little tricky, okay? For the x-intercept, remember you put a 0 in for y. So here's basically your y. I put a 0 there. Now, because I don't want this fraction, I'm going to multiply the entire fraction, or excuse me, I'm going to multiply the entire equation by this right here. And I did not mean to do that, and I wished I had not done that. Let's try this again. There we go. Now please watch this carefully, students, okay? You say, Mr. Gerard, I'm lost. Okay, watch again. I'm trying to find the y-intercept. So if you're trying to find the y-intercept, excuse me, that's incorrect, I apologize. You're trying to find the x-intercept. So if you're trying to find the x-intercept, you put 0 in for y. And here's y right here, and I put a 0 in for y. Okay? Now, having done that, I'm going to solve this equation. Well, as soon as I set this equation up, I realize I have a fraction that I don't want. And we know by now, you guys have had class with me all year, whenever I want to eliminate fractions in an equation, I multiply the entire equation by whatever the denominator is. So if I take this here times 0, anything times 0 is just 0. If I take this fraction times this fraction, this denominator will cancel with this, and I'm left with 2x plus 3. Now, can I please show you a shortcut, men? Please let me show you a shortcut. I did not want to just throw this thought at you until I showed you why. In rational functions, whenever I ask you to find the x-intercept, you can really just take the numerator and set it equal to 0. Isn't that cool? Isn't that easy? So somewhere make a note of that in your notes. Whenever you're looking for the x-intercept, you can take just the numerator and set it equal to 0, and that's the exact same thing as putting 0 in for y. Now that only works for rational functions, but it's a nice shortcut, okay? So we're going to bring the 3 over and make it a negative 3, and then divide by 2. So we get negative 3 halves equals x. So now I know for sure the graph is going to cross the x-axis at negative 3 halves or negative 1.5, which is right here. There. Now that's pretty helpful, guys, okay? So we've accomplished steps 1 and 2, and now you see why these take so long, okay? Because really we have a lot of work to do now. I mean, quite a bit. So now, Caleb, it is true that a graphing calculator would be very helpful for these problems, but you don't have to have one, okay? But they are going to be helpful. Look what we do now. We're going to evaluate x values on the left side and the right side of each vertical asymptote. So let's start with this vertical asymptote right here. Do you see it? Let's plot values to the left and kind of see what's happening. So negative 1, 2, 3. I'm going to put in negative 4, negative 5, negative 6 real quick. Negative 4, negative 5, negative 6. Now I already have this typed into my calculator, and so negative 4 is going to give me negative 0.4. So negative 0.4. Negative 5 is going to give me negative 0.2, and I'm rounding, of course, negative 0.2. And then negative 6 is negative 0.15. Okay? So it looks like it's getting closer and closer to this horizontal asymptote. Let's see. So at negative 4, I'm at negative 0.4, right here. And then at negative 5, I'm at negative 0.2. And then at negative 6, I'm getting closer, negative 0.1. So I think you're kind of getting the picture. It looks like the graph is going to come like this, hit here, and get closer and closer to that horizontal asymptote. Now, men, look at step 3. Are you ready? Read it with me carefully. Be sure to include values that are what? Very close to the asymptote. So if I have an asymptote at negative 3, I want to go barely past it, and with my calculator I'm going to type in negative 3.1. Negative 3.1. And I'm getting out negative 3. I rounded that, okay? So I know I'm way down here at negative 3 when I get close. So that confirms what I thought, is getting closer and closer to this asymptote, but not crossing it. So there, we have one piece of the puzzle finished. Now we're going to solve for, now we're going to find the values in between the two asymptotes here. So I need to put in values, let's see, negative 2, negative 1, and 0. So negative 2, negative 1, and 0. Let's see what we get out, okay? Negative 2 is going to be 0.125. Negative 1 is going to be negative 1. And 0 is going to be negative 0.5. So let's plot these points. At negative 2, I'm going to be at 0.125, so about right here. And then at 1, I'm going to be at negative 1, so right here. And then at 0, I'm going to be at 1/2, which I already knew that anyways. I'm not sure why I did that, okay? All right, now please watch carefully what I'm going to do. I want to see what the graph is doing really close to the asymptote here and really close to the asymptote here. So I'm going to put in numbers like negative 2.9. Wouldn't that be real close to this? Think about it. Negative 1, negative 2, negative 2.9. I'm getting really close. I'm getting really close to this asymptote right here. Also, if I'm going to get really close to this asymptote, let's count it down. I would be at, let's see, here's negative 2, negative 1, 0, and then not quite to 2/3. Okay, so maybe we'll just put in 2. Okay, I'll tell you what, 2/3 is 0.666. So I'm going to put in 0.5. That's pretty close, okay? 0.5. So let's see what we get out here, okay? Here we go. Let's go with negative 2.9, and I'm getting out 2.6. All right, now let's type in 0.5, and I'm getting out negative 2.3. Of course, I'm rounding these, negative 2.3. So when I get real close to the x-axis, I'm getting real close to the asymptote right here, negative 2.9. I'm going all the way up to 2.6 right here. And then over here, when I get real close, 0.5, I'm going down to negative 2.3. So 0.5 is negative 2.3, about right there. Now, if you notice me pause the video, I apologize, but I've taught this math for years, and 2 plus 2 was not adding up to 4. So I said to myself, I thought the graph right here in the middle would look something like this. Come down, hit, and then continue on. The only problem with that is this point right here, or this point here, was kind of throwing me off. So remember over here when I said negative 1 is negative 1? Well, I guess my vision is starting to go. I didn't see the point, so fix that in your notes. So this point right here should not be there. It should be negative 1, negative 0.1. And I kind of looked at that and I was like, there's just no way that's accurate. So let's see if we can get the eraser to work on this. And I guess the eraser is choosing not to work today. Still no good. Let's try it now. There we go. All right. So really it should be right here. Okay, that gives me a pretty good picture of it, does it not? Comes down, hits here, curves a little bit, hits here, and then it shoots straight down. So it's getting closer and closer to the right and left asymptotes, never crossing. Now, here's one of the examples that I warned you about where sometimes the graph will cross the horizontal asymptote. And it did right here, and that's okay. That'll happen occasionally. Now, let's go ahead and see what's going on with this asymptote here. I want to go to the right of this asymptote. So I'm looking at, and I'll put in 1. Actually, 1's really close to 2/3. So I'm just going to put in 1, 2, 3, and 4 and see what I get out. Okay, so here we go. For 1, I'm getting 1.25. For 2, I'm getting 0.35. For 3, I'm getting 0.21. And for 4, I'm getting 0.16. So we can see it's getting closer and closer to 0. So at 1, I'm at 1.25. And then 2 is right here. And then 3 is getting a little closer. And then 4 is getting a little closer. So you should kind of get the idea. The graph's going to come up, hit here, and get closer and closer to the horizontal asymptote and closer and closer to the vertical asymptote, but never cross it. Okay, now you see why I'm just giving you 5 of these in your homework and just 3 in your notes. Okay, they take a little bit of time, guys. That's how hard math is. Okay, so there we go. We graphed your first rational function, so pretty exciting. All right, let's go on to the next problem in your notes. Okay, let's find all the asymptotes. So step 1, let's find the vertical asymptotes. Here we go. You take your denominator and you set it equal to 0. Of course, we're going to factor that. What two numbers multiply together will give you negative 6. When added together, will give you a positive 1. I'm thinking positive 3 and negative 2. Okay, now for this parentheses, one of your zeros would be a negative 3, and for this parentheses, a positive 2. So there's your vertical asymptotes. You just found your vertical asymptotes. So I'm going to put a dotted line here at negative 3 and a dotted line at positive 2. Positive 2. All right, and we're not looking for perfection, but try to be as neat as possible. And I'm trying to do the same thing. Okay, there we go. Vertical asymptotes found. Now, horizontal asymptotes. Well, horizontal asymptotes, whenever the degree is smaller in the numerator, you have a horizontal asymptote at 0. Whenever the degrees are the same, you have a horizontal asymptote at lead coefficient over lead coefficient. What is your lead coefficient up top here in the numerator? 1. And what is your lead coefficient here in the denominator? 1. So you put 1 over 1. If this would have been a 2 right here, then you would put 1 over 2. And you would have a horizontal asymptote at y equals 1/2. Okay? In this case, we have 1 and 1. So 1 over 1 is 1. So we have a horizontal asymptote at 1. Easy enough. Horizontal asymptotes are pretty simple, guys. Okay, really not a lot of work to show on those. Okay, moving on now to slant asymptotes. I didn't mention that in the last problem. Remember, slant asymptotes only exist when your numerator is 1 degree higher than the denominator. Okay, so we have no slant asymptotes. Now let's find the y-intercepts. Everywhere there's an x, I'm going to put a 0. So x squared minus 1 over, or 0 squared minus 1 over 0 squared plus 0 minus 6. Well, 0 squared minus 1 is negative 1. 0 plus 0 minus 6 is negative 6. Negative over negative is a positive. So I have a y-intercept at 1/6. Kind of weird, but that's where it is. So really small right there. Okay, all right, now let's find the x-intercepts. Remember how I told you to do that? Usually you put 0 in for y, but for rational functions there's a shortcut. You can take the numerator and you can set it equal to 0. All right, x squared minus 1 equals 0, and solve that, and that will be the x-intercepts. So bring the 1 over, make it a positive 1, take the square root of both sides, and we get plus minus 1. So now we know we have x-intercepts at positive 1 and negative 1. That really is a big help. And now we're ready to roll. So here we go, guys. Let's go ahead and get started. Let's first of all plot some x values to the left of your first vertical asymptote. So negative 1, 2, 3, negative 4, negative 5, negative 6, negative 4, negative 5, negative 6. Let's see what we get out very quickly here, okay? For negative 4, I'm getting 2.5. For negative 5, 1.7. And for negative 6, 1.5. So here we go. Negative 4 is at 2.5. Negative 5 is at 1.7. Negative 6 is at 1.5. I think you can see what it's doing here is coming down and getting closer and closer to this horizontal asymptote. Okay, now what about going up? Well, more than likely it's doing this right here, but let's make sure. I mean, I don't want to be too annoying, but let's make sure. Let's get real close to this vertical asymptote, negative 1, negative 2, negative 3. I'm going to very quickly put in negative 3.1. And when I do that, I get out 16. So it's shooting up really quickly, okay? Now let's go ahead and plot some points in between your two vertical asymptotes. So looks like we're going to put in numbers like negative 2, negative 1. I don't need to put 0 in because I know already 0, 1/6 exists, okay? And then actually I don't need to put negative 1 in either because negative 1 is 0. And I don't need to put 1 in. I know 1 is 0. So there we go. So let's put in negative 2 real quick, and let's see what we get out. Negative 2 is negative 3/4. So let's get a little picture of this. Negative 2 is at negative 3/4. And then I've got this point here and this point here. I'm kind of curious what it's going to do really close to the asymptote. So negative 1, negative 2. I'm going to put in negative 2.9. And I want to see what it's doing really close to this asymptote. So I have 0, 1. I'm going to put in 1.9. And let's kind of see what happens here, okay? So let's go to my calculations here, negative 2.9, and I'm getting out negative 15. So it's obviously shooting way down like this and getting closer and closer to the asymptote, but not quite hitting it, okay? I think you're going to get kind of a parabola-shaped graph here. Okay, let's go ahead and try 1.9. We'll get out negative 5. So we know it's shooting down here also to about negative 5 and then going on down. Okay, so that's a pretty good sketch. Remember, we're just sketching it. It doesn't have to be perfect, but that's a pretty good idea of what the graph's doing. Now, I'm not the smartest person around, but more than likely with a vertical asymptote here and a horizontal asymptote there, more than likely we're going to get a graph up here or we're going to get a graph down here. So let's see what happens, okay? All right, let's go ahead and plot points 1, 2, 3, 4, and 5. I'm going to put a 3, a 4, and a 5 in. And using my table of values, I will get out 1.3 for the 3. For the 4, it's going to be a 1.1, and then for the 5 it's going to be a 1. So at 3 we're at 1.3. And at 4 we're going to be at 1.1 right here. And that's not the best here, hold on. 3 would be 1.3, 4 is here. Now, you did see me pause the video because I was a little concerned. I wanted to make sure I hadn't made a mistake, but I did not. So this again is another example where the graph is going to cross the asymptote, the horizontal asymptote, okay? So we're at 3, 1.3. And we already put in 1.9 and got 5, so it's up here somewhere. So we know the graph is coming down. It's going to hit here. And then remember, at 5, 1, 2, 3, 4, 5. At 5 it's 1. So I went ahead and put some more points in to see what it did. And here's what it's going to do. Is if you will substitute in 6, 7, 8, 9, 10, which I've done here in my calculator, you're going to see it dips under the asymptote, takes a little bump here, and then goes back up, and it gets closer and closer to the horizontal asymptote, but it never crosses it. Now, on a test or a quiz, how strict would I be on you getting this little bump right here? Maybe not super strict, but I would want you to show me that it definitely hits the horizontal asymptote here and continues under it, and then it does not come back up again. Okay? So really nothing earth-shattering here or nothing new. None of the steps changed. Just make sure you're putting in values and getting out the right values and then plotting them correctly, okay? And as soon as I saw that 5 gave me out a 1, that's when I paused the video and I was like, wait a second, let me make sure that I'm right. And I was right, and so everything is normal. Remember, sometimes horizontal asymptotes will be crossed. Vertical asymptotes will never be crossed, okay? All right, and then moving on to our last problem, and we're finally done, okay? Step 1, let's find all of the asymptotes. Take your denominator, set it equal to 0, x minus 5 equals 0, move the 5 over, x equals 5. So we have a horizontal asymptote at 5, okay? There we go. Now let's find our horizontal asymptote, and notice there isn't one. The degree up here is higher than the degree in the denominator. So we do not have a horizontal asymptote. Anytime the degree is higher in the numerator, there is no horizontal asymptote. However, notice the numerator is exactly 1 degree higher than the denominator, so we do have a slant asymptote. So we got to very quickly use long division and find that slant asymptote, okay? So x goes into x squared x times. Do your multiplication, you'll get x squared minus 5x. Now instead of subtracting, I would encourage you to change the signs and just add. So those cancel, and you're left with negative x. Now there is no constant term here. You might just want to put a 0 and bring it down. You're probably going to need that. Okay, now x goes into negative x, negative 1 times. Negative 1 times x is negative x. Negative 1 times negative 5 is a positive 5. Change your signs and add. These cancel, and you're left with negative 5. Now remember, when you're looking for a slant asymptote, you do not care about the remainder. All that you care about is the quotient part. You take the quotient, x minus 1, and you set it equal to y. So y equals x minus 1 is your slant asymptote. Now, I'm going to pull that up top so we have that to look at later if we need to, okay? But the only way to put your slant asymptote on this graph right here is to graph this linear equation. Can that not be done so easily, students? Man, just very quickly put some numbers in for x. Put in a 0, a 1, and a 2. Put a 0 in for x, you get a negative 1. Put a 1 in, you get a 0. Put a 2 in, you get a 1. So we know the slant asymptote is at 0, negative 1, 1, 0, and 2, 1. So your slant asymptote, you might want to get a straight edge and make sure you're doing it well, unlike your teacher right now. And there's your slant asymptote, okay? There we go. Now moving on to step number 2. Find the X and Y-intercepts. Okay, let's put a 0 in for X. We would have 0 squared minus 6 times 0 over 0 minus 5. Well, your whole numerator is going to be 0, so 0 over negative 5 is 0, so your Y-intercept is 0. There we go. Now let's find your X-intercept. Remember the shortcut that I taught you? For your X-intercept, you take the numerator, x squared minus 6x, and you set it equal to 0. Well, let's factor out an x, and we're left with x minus 6. So for this group here, I would get out 0. For this group here, a positive 6. So my X-intercepts are at 0 and 6. There we go. Now we're on to the last step, guys. Not too difficult, okay? Let me get a drink here. And now step 3 says evaluate x values to the left and right of your asymptote, vertical asymptote. Well, I only have one vertical asymptote. It's at negative 5 or positive 5. So let's try 4, 3, 2. I'm going to put in 2, 3, and 4. So let me quickly turn my calculator on, and let's see if we can't do this. And let's see what we get here. All right, here we go. For 2, I will get out 2.7. And for 3, I will get out 4.5. And for 4, I will get out an 8. So I go over 2, up 2.7, so about right here. Go over 3, and I would go up 1, 2, 3, 4, 4.5, right here. And then for 4, 1, 2, 3, 4, I would go up to 8, so somewhere up here. So it looks like to me the graph is hitting right here, hitting here, and then notice how it's getting closer and closer to your vertical asymptote over here. Going down this way, it's probably just going to get closer and closer to your slant asymptote, okay? In fact, that's exactly what it's going to do. Now, if you weren't sure about that and you wanted to plot some more points to the left of your slant asymptote, you could do that. Put in a -1, -2, -3, -4, and you'll see it's going to continue going down like this, okay? All right, now let's plot some points to the, well, I didn't get really close to the X, to the vertical asymptote. I guess I could have put in 1, 2, 3, 4, 4.9. And I will do that very quickly. You're going to get a really high number. You're going to get 53. So at 4.9, you're going to shoot way up here somewhere. Now, let's go to the right of my vertical asymptote. I already know 6 is right here at 0, so I know I have 6, 0. Let's try 7 and 8 real quick and just see what happens, okay? I know we're kind of running out of room, but 7 would give you out 3.5. 8 would give you out 5.3. So 7 is going to be 3.5, 1, 2, 3.5. And then 8 would be 5.3, so 3, 4, 5, about right here. All right. 5, 6, 7, 8. About right here. And then it's also going to, if you'll put it, I'm going to go ahead and put in 5.1, and you're going to see you'll get a really low number. You're going to get, yeah, negative 45.9, so it's going to shoot. We know for sure it's going to hit here and start shooting way down close to your asymptote. Now this is like kind of a wide parabola. It's going to hit here, and then listen, if this vertical asymptote, if this slant asymptote continued on, which it did, this green thing here would just follow the slant asymptote just like it did right here. Okay, and that's it, guys. What you need to do now is practice, which is pretty much the dreaded word for any high school student, but you do need to practice. And so here's your homework. If you can take a look at this real quick. I've only given you 5 graphs, 1, 2, 3, 4, 5, and then these here are kind of an added bonus. No cheering. I know you're excited about that, but you'll see those when you get to them. But there's your homework. Go ahead and get started. Call or email if you have any questions, and definitely use the homework help video to help you if you need to.